Okay, so category 7 of popular types of FRQ questions. Here we go. Function built from another function. Look, they're just going to give you a bunch of values for f, f prime, f double prime, g double prime, blah, blah, blah. And they are going to ask you to find derivatives, and you're going to have to use chain rule and quotient rule and product rule. And then at times they're going to ask you questions about the mean value theorem and the intermediate value theorem. So just make sure that you know them. The intermediate value theorem is that one where all your y values in between f of a and f of b are included. And the mean value theorem is just where a rock is equal to the derivative. You've done enough of these. We'll do some in here, but you need to know those and be able to use their definition to justify things. So we're only going to do a couple problems, and this one is actually from the 2023 exam, so it's really recent. And they give you this table of values with derivatives for f and g, and first question is, let h be defined by the function h of x is equal to this composite function, find h prime of 7. So you're going to be using chain, right? Because we have an outer and an inner. So it's the outer guy's derivative, so with the stuff plugged into it, times the inner guy's derivative. That's what h prime is equal to. And if we're looking for h prime of 7, it's just going to be, we're going to plug 7 in. Then we're just going to use the table. So we're going to come over here first, and we're going to do the inside. G of 7 is 0. So this becomes f prime of 0. G prime of 7 is 8. Then we're going to find f prime of 0, which is 3/2. So we've got 3/2 times 8, which is 12. This scores, I didn't score this, but you get the general idea on scoring. And this next one, you're given this definition for k prime. So that's the first derivative. Is a graph of k concave up or concave down. That's going to be, we're going to look at the second derivative to determine concavity. We're using x equals 4, and we need to give a reason. So we're going to have to use both the product rule here for the f part and the g part, and then for the f part, we've also got to use chain rule. So it's just an issue of being pretty careful. So we're going to take the derivative of the derivative function. So that's going to be 2 times f of x, that's the inner, times the derivative of the inner. So that's f prime g, okay, plus g prime, the second guy's derivative, times f, which is f of x squared. Then we're going to plug x equals 4 into this. Right, and then we're going to just use our table above and pull the information out. So that's going to be 2 times 4 times 3 times negative 3 plus 2 times 4 squared. Do the arithmetic and you end up with negative 40. Okay, so since that is negative, we're going to answer the question. K double prime is less than 0. So K is concave down at x equals 4. So there's my reason, there's my answer, and there's my derivative. Those are probably the 3 places where you're getting points. All right, so here we are at part C, and again, it's just really, these questions are just really giving you a chance to show that you know what all this notation means and how to find derivatives and antiderivatives and that sort of thing. So they give you this function, m of x. They want you to find m of 2 and show your work. Okay, no problem. All right, m of x, the first part is really straightforward, 5x cubed. And here, what we're going to do is we're going to see that we've got an integral and a derivative. We're going to use a fundamental theorem of calculus part 2. And this just simplifies to f of x times the derivative of x, which is 1, f of 0 times the derivative of 0, which is 0. Okay, that wasn't too hard. So now I'm going to find m of 2. So that's going to be 5 times 2 cubed plus f of 2. So that's 5 times 8, which is 40. And f of 2 is 7. So my answer, easy peasy, is 47. And on to part D. In part D, they want us to use the function m mentioned before, so I just wrote it out here for us. And they want to figure out if it's increasing, decreasing, or neither at x equals 2 and justify your answer. So increasing and decreasing, we base on the sign of f prime. So let's find m prime. That's just 15x squared plus f prime of x. And if I find m prime of 2, it's just 15 times 4, which is 60. F prime of 2 is negative 8. So my answer is that it's greater than 0. Okay, so it is increasing. Rather, I should say m is increasing at x equals. M is increasing because m prime of 2 is greater than 0. There you have it. And that's it for that problem. One more problem and we're done. So for number 6, we've got this table of values for G. We've got a graph of H. And they tell us that f is the function defined right here. It's differentiable. Okay, good to know. In part A, they say find the slope of the line tangent to the graph of x at, find the slope, okay, slope is derivative, okay, to the graph of f at x equals 5. Okay, so I guess I need to find f prime. So f prime of x, got to use chain here, okay, the 2's going to come out front, and derivative of cosine is negative sine, so this is negative 2 sine 2x. They're really just saying if you know how to use chain, okay. The next one, you also have to use chain. So you're going to take the derivative of sine, which is cosine x, and bring that out front, e to the sine x. Okay, now we're just going to do f prime of pi. And just in case you haven't considered that you really need to know your trig, you do. Now's the time to learn it. Time's running out here. Okay, so sine of 2 pi is just 0, so that whole first term goes away. Cosine of pi is negative 1. Sine of pi is 0, so negative 1, e to the 0 is 1. So your answer, f prime of pi, is equal to negative 1. Let's go to the next one. All right, part B, here again, they're asking us to find a derivative. We're going to use chain rule, so let's go ahead. They want us to find k prime of pi, so k prime is equal to h prime of f of x. That's the derivative of the outer times the derivative of the inner. You guys should be awesome at this by now. Then we're going to look for k prime of pi, so that's h prime of f of pi times f prime of pi. So we need to do a little side work here. Let's figure out what f of pi is. So that's going to be cosine of 2 pi, well that's 1, plus e to the sine of pi is 0. So this is 1 plus e to the 0, 1. So this becomes just a 2. F prime of pi we found in the previous part A, that was negative 1. So we're now looking at h prime of 2 times negative 1. H prime, derivative is slope. We've got a graph of h. If you come over here to x equals 2, you can see that your slope is negative 1/3. So now we're dealing with negative 1/3 times negative 1. So your answer is k prime of pi equals 1/3. All right, this one you've got this function m that we're going to have these two functions here. So we're going to have to use product, and we're going to have to use so m prime is the derivative of the first guy. So that's -2, that's the chain, times g prime of -2x times the second guy, this is product, plus the derivative of the second guy times the first guy. And now we're going to plug in 2. Okay, and then what we're going to do is to evaluate this. So this becomes -2. G prime of -4, I'm going to go to the table, is -1. H of 2, I'm going to go to the graph. Looks like that's -1/2. Typically, those are drawn a little bit more clearly, so you know, but I checked the answer and that's correct. Okay, H prime of 2 is the slope at 2 of my graph of H, and we already figured out that that was -1/3. And then G of -4 is 5. I do the arithmetic, and I end up with -8/3. So just be careful with the arithmetic. All right, part D, what should jump right out there at you is there a number C? Okay, that right there, you should be highly suspect of the mean value theorem. That's when you're going to show that f prime of C is equal to the average rate of change on the interval. So what we're going to do is we're going to first find a rock on -5, 3. So that's going to be g of -3 minus g of -5 all over -3 minus -5. Okay, you're going to plug stuff in from the table. You're going to have 2 minus 10 all over +2. So that's -8 over 2, which is -4. Oh, yay, we can use the MVT. So now we're just going to justify by wording that correctly. Not going to forget the prereq here, which is showing that G is continuous, and we can justify that because they gave us that it was differentiable. Okay, now we get to the MVT guarantees. It's going to be words to this effect. Okay, that's number 6.